Hi, so I'm Owen Taylor. I'm a software engineer at Red Hat. I do various things related to our desktop distribution, but one of the things I've been working on recently is getting Flatpaks to build within the Fedora infrastructure. And I want to talk about first why you would do that, and then how we're actually going about doing that. So, there's been several sessions here on Flatpak, so hopefully people are familiar with the basics now, but I wanted to just review the parts that are maybe most important to this talk. So the basic model of Flatpak is you have your operating system, and then alongside that you have a number of applications which depend upon runtimes. So when we actually go ahead and launch one of the applications there, we have an isolated file system namespace that has mounted in it two different separate things. It has the application mounted into it @/app, and then it has the runtime mounted into /user. And so the runtimes are shared among many applications. Well, then every application has its own /app. So to build a Flatpak, you build Flatpak runtimes. You create these file systems you mount at /user. To build Flatpak applications, you build file systems that you mount at /app. So, in Alex's talk, he talked about the sort of upstream approach to doing this. The Flatpak runtime, the upstream one, is built essentially directly from the upstream sources, and basically is one big unit. And then the application, along with the big runtime that you're going to use at runtime, there's an SDK which contains the compiler, the header files, everything you need to build applications. Then there's a tool, Flatpak Builder, which takes the SDK and the sources of your application and then builds that directly. So that's the sort of upstream model, and it's working. But it's not the only way to build a Flatpak. Flatpak is about how you run it. It's not about how you build it. So from the start, Flatpak has supported, possibly building in many different ways. And the distribution approach, what this is talking about, is actually taking the runtime and making it out of distribution packages, which is, I guess, something that Endless has also done, and then taking applications and also building them out of application packages. The runtime is in /user, so it's a standard Linux file system with so you don't actually have to rebuild the packages there. You can just use the packages as they exist. But to take a distribution package and have it in /app, you actually have to rebuild it. You have to use different build settings to make sure that it ends up with the right prefix. Usually you can't just take a binary from /user and copy it into /app and expect it's going to work. It's going to look for particular files in particular places. So why do you want to do that? Well, basically you want to do that to take advantage of things that are already going on in distributions. Distributions usually have a security process. When some kind of security hole is announced, they know how to find the packages that it affects, rebuild them, release them, tag them with the right CVE number. So that means that if you can build your runtime from distribution packages, then you can figure out how to automatically rebuild it whenever there's a security vulnerability, and you don't have to worry about that separately. You don't have to create your own process. There are also distributions often worry about taking a single stable code base and maintaining it for a defined support lifetime, either 18 months with Fedora, or sometimes 3 years or 5 years. So, if you want to say, I'm going to have a Flatpak runtime that I want people to build an application on, and I know it's going to be supported for 18 months or 3 years or 5 years, if you can build your runtime out of distribution packages, then that's going to get you a long ways toward having that. And then finally, those are sort of, on the other side, what we just want to take advantage of the fact that Fedora already has a large number of applications in it. I mean, FlatHub currently has 185. Fedora has over 1,000 different applications in it. So if we can provide an easy way for maintainers of packages to say, I'm going to take this package, I'm going to rebuild it, and I'm going to have a Flatpak, then that's a way of increasing the number of Flatpaks available. And when these Flatpaks are available, they're not going to be only able to run on Fedora, they can be run anywhere. So that's a way of accessing this sort of back catalog of applications that maybe don't have an upstream maintainer who really cares about them. They don't have anybody who can put them onto FlatHub, but they do have a Fedora maintainer who can potentially get them into a Flatpak. So, the basic outline of how we're doing that is we're using modularity and defining runtimes and packages as modules. We're going to build Flatpaks as OCI images. And that's going to allow us to treat a Flatpak just like a container, like a server-side container. And we're going to put it through the Fedora infrastructure just like a server-side container. And then we're actually going to store them on the same Docker registry that we store the server-side containers for Fedora. And let me go into these steps in some more detail now. So why modularity? So I mean, you probably are somewhat familiar with modularity and the idea that it's going to give packagers and users more flexibility in how we build the operating system. In essence, it's taking the global package space and breaking it up and saying we don't have one Fedora 28, we can have Fedora 28 and then we can have 2 versions of MongoDB on top. So, but this idea of breaking up the space for building and for running is really useful for Flatpaks. One thing we use it for is this idea of the rebuild process. So say I have a library that's I'm bundling into my application, I need to rebuild it. So if I just had a single big Fedora 28 package space, then libping would have to be either built in /user or /app. It couldn't be built both ways. But I mean, libping is not a great example because it's really going to be part of the runtime, but a different, more specialized library would be part of the application. So being able to rebuild it in /app and not conflict in the global Fedora 28 package space is an important thing that modularity gives us. It also will, over time, give application maintainers the ability to say, my library needs a different version of this. It doesn't need the version that's in Fedora 28. It needs a newer version. Maybe it doesn't work with the new version that's in Fedora 28. I need an older version of a library. We're giving more power to the application maintainer. So all of these fit in very well with what we're doing with Flatpaks. The next step I said is OCI Images. So the sort of native format for a Flatpak is an OS tree. And OS tree is just a Git for file systems. It's like it says, we're going to look at all the files in the file system, and we're putting a big tree, and we're going to do a very efficient compression on it. But Flatpak also has built-in support for OCI images. And OCI images are a sort of standardization of the Docker image format. And because Flatpak is just a file system, if we have some other way of representing a file system, in this case an OCI image, that we can also put a Flatpak into there. And so what's the manage this? Why do we want to go away from the OS tree model? Well, the main reason is what I said earlier, is that we want to be able to treat them just like a server-side container. If we really had 2 different things, we have to pass our applications as, you know, we already have RPMs, now we're going to say we have Docker containers, now we have OS tree Flatpaks. This puts a lot of pressure on release engineering, puts a lot of pressure on sysadmins who want to deploy applications across a large set of computers, and they have to figure out 2 ways of doing it. So saying, okay, we can just treat it like a server container, simplifies things a lot on the sort of release engineering side in particular. It also avoids a lot of little small files, which in some circumstances can be a big advantage on the network. Some other cases, it might make things less efficient. Depends if you want to have a lot of little small files or less efficient big files. So once you have it in the repository, it's going to be completely hidden behind Flatpak. The user doesn't care if the remote is an OS tree repository like FlatHub or a Docker repository or OCI Registry. So that's the user point of view is they just have an URL to a Flatpak repository, and they don't have to care what the format is in there. And when things are installed on disk, they're going to be stored the same way. So it's just a question of how you get the Flatpak. So the first thing you have to do in Fedora to create a Flatpak is create some files for the module there. There's basically 3 files. A module.md file, which says what goes in your module. Container.yaml says how do I build my module into a container, or how do I build a container, and it points back to the module. You'll see that it's the most trivial file. And finally, the flatpak.json, which contains metadata for the Flatpak, which is saying how to actually run the Flatpak. So let's see how it looks. So this is the module.md file. It has a description. It has, it says which runtime it uses, has license, and then it lists a bunch of things to build. So the I have GNOME image viewer uses I have GNOME. It uses a library for metadata. maybe has like 4 bundled libraries in it. So that's the module MD file. The flatpak.json has, the main thing it has in it is this finish args, which describes the permissions. As Alex said in his talk, look at man flatpak build finish if you need explanations there. And hopefully we're going to have dconf support more natively, and most of this stuff will go away because it's all about how to talk to dconf and get your settings for your application. And then finally, the container.yaml, as I said, is the most trivial file. It just says, this container is built from this module. And this is actually still a work in progress. It's not fully, it might not be exactly like this, but it's going to be something like that. And maybe we'll actually merge it with the flatpak.json so that people don't have to deal with 3 files. We could put everything from the flatpak.json into this file. Okay. So that's like the files you created. Then it looks a lot like building a package. You do fed package module build, and that tells the module build service to go out and build all those RPMs that we listed. And then so builds in Koji, and then the source metadata into something called the product definition center. The second step is going ahead to build it. And then again, it's a fed package. Instead of doing module build, you do flatpak build. And then this uses OSBS. Now, OSBS is a pretty complex system, but from the packager point of view, you don't have to care a lot about it. It's going to finally tell. So end up putting something in the Fedora candidate registry and tell you, here's the image that you can go download and test out. So how do you get it from this candidate registry to the final registry? Well, that's the last step. It looks a lot like, it will look, this is not done yet, but will look a lot like doing a package there. You need to create a Bodhi update saying, here's what changed. And then you can do testing, either automated testing or manual testing. And then once pushed to stable, it'll be copied over to the stable registry. So those are that's sort of in very brief outline the steps involved there. If you're building a runtime, which is not something that most people will do, but people who are maintaining the runtimes will do, it actually works basically exactly the same way. There's a module that says what goes into the runtime. You build the runtime in the OSBS and gets put onto the registry. So it's actually exactly the same process. And then there's a final detail I wanted to mention here, is that I said I'm going to just put the Flatpak onto the registry, and then that will be enough for GNOME software to download things. But that actually isn't true, because the way that the upstream Docker registry code works, it doesn't want you to let you get a lot of data about the registry. It's very non-browsable. On the other hand, GNOME software needs to be able to go out and say, well, what are all the applications available? What are the names? Where do I get the screenshots? So we need to get all this rich metadata in a compact way without making thousands and thousands of calls into the registry. So we wrote an index server that sits alongside the registry, gets all the data from the registry, and makes it available in a much more queryable fashion. And that is what GNOME software is actually going to talk to find out what's available. Then when you download something, you'll go and talk to the registry directly. So this is... yeah.
Just with Flatpaks, or?
No, it is completely, I mean, people are interested. I've talked to various people about it, and I think there's some general interest. I haven't, but it's, does Docker image, it indexes both Docker and OCI images. It's, anybody who wants to build a nice interface to a Docker registry can use it. It could be used to provide search across the registry too, which is something that there's no provision for in the Docker distribution code. So it's
Docker OpenShift registry both potentially taking it?
I haven't talked directly to them, so I'll some people I have to reach out to. This is all the stuff I just talked about in form. It looks a lot more complicated like that than the actual package review, so I'm not going to spend much time on that. And that's actually a simplified picture. Okay, so we had these multiple steps to go on. One thing we're going to be heading toward is having automation, so that if, say, when there's a security update going out, you don't need to find out about the security update and manually rebuild your Flatpak or your runtime. We want that to happen automatically. We want it automatically file an update into Bodhi, and then, if necessary, hopefully even have the security update to your module, your Flatpak go automatically without you having to sit there and give it karma or anything like that. Because it's only going to work if people aren't manually having to do a million things. So automation is something still in planning, but we're going to do definitely. What's the status? So all the stuff on the left has been written. So we have the OCI support in Flatpak for a long time. We have code for OSBS for Flatpaks. We have code to put for OCI support. All the stuff I'm working closely with the Fedora infrastructure people to deploy. Hopefully within the next month or so, we'll actually have that live. There's still, once we get that going, there's still some stuff we need to work on. Having good generation of all these files that you need to write, so you can very easily turn a package into a Flatpak. Automatic rebuilds, as I said, signing is something else we have to deal with. And when I talk about Fedpak integration, I actually was also giving something that doesn't exist yet. Currently, you have to use more low-level commands. So, any questions? Yeah?
So you first make a module, and
Yeah.
then you make the image, container image.
Yes.
Of that module. Is that module visible somewhere? Could I by accident install it? Or?
I think you currently, well, it's not, currently you can only DNF install modules which are part of the compose. That's how the DNF support works currently, and we're not composing these, so you would not be able to accidentally install that. If we ever add support for DNF for going out and getting arbitrary modules from Fedora, then we'd have to make sure to somehow exclude these, because if you accidentally installed it, it's not going to work correctly on your system, because it depends upon this different namespace setup.
Modules don't end up in the Fedora repository unless they're whitelisted in.
Yeah.
So these won't be. So
Yeah.
fine.
Yeah.
Do you foresee dependencies between RPM packages and Flatpaks in either direction?
No, I mean, certainly, the idea of a Flatpak is self-contained, so it shouldn't depend upon RPMs. And I mean, generally it's a separate way of doing things, and they shouldn't be intertwined together, just so that you wouldn't have dependencies between Docker containers and RPMs. Yeah.
Do you think FlagState will have a web interface for like humans to?
So there's a very simple web interface now, which is like a flat list of everything in there. It's sort of a question of how much people want to put effort into making it nice. It could be made arbitrarily nice into a real app store type browsing, searching interface. It's just a question of.
We have this like registry browsing thing now that I think doesn't work, but it'd be nice to like make them gel or something.
Yeah, no, I mean, it has all the information that you need to do the nice web interface, so it's just a question of writing the web interface.
Yeah.
And I don't want to put too much effort into,
Sure.
make it too fancy, but somebody else definitely could. Yeah? Was a question in the back there? No? Oh, yeah.
So will this result in Fedora runtime? Will I be able to install the Fedora runtime on my Debian machine and run the Fedora Flatpaks based on that runtime on that machine?
Yes, you will be able to. So that's sort of inherent property of Flatpaks. It doesn't depend upon the host system. It's all localized. Yeah?
How does downloading Flatpaks from an OCI repository compared to just doing the OSB?
So the question, I guess I should be repeating all these questions, but the question was how does downloading a Flatpak from an OCI repository compared to from an OS3 repository? So generally, it's going to be less efficient because an OCI image is basically a big tarball of your whole file system. So there's none of this clever deduplication that happens on the OS3 level. That's it is in some ways more efficient too because if you don't have deltas generated for an OS3 repository, then every file gets downloaded as a separate HTTP transaction, which can be a pretty heavy load. So, in some ways, if you have lots of bandwidth, then you're sort of cutting out of some of the intermittent latency that might actually be faster. we're talking about how to get back to having the same delta properties, and there are some ways we could do it that would require extra, basically extra coding, extra server resources, but we could have essentially a delta protocol to say, I want this layer from an OCI and that layer, give me the delta between that. We could possibly even explode OCIs back into OS3 repositories at the end for download. So there are possibilities, but for the short term, it's going to require more bandwidth. Dan?
Any effort on Fedora to basically get all apps that want to ship with Flatpak or
So the question was, is there an effort to make apps automatically build? I think that, I mean, currently there's not, I mean, we have to get first to the point where we can do some apps manually before we can talk about how automatically we can do it. I think I'd rather have the packagers involved, at least. Hopefully we can make it very, very simple for the packagers to do it, but I think doing entirely automatically, I mean, first there's the idea that you sort of do need to verify what resources the application needs and what security permissions it needs, though you could just default that to be open. But I think essentially I would like packagers to be actively involved if possible, so I don't want to just impose this on them without understanding what they're doing.
Right, I'm looking for packages basically that build Flatpaks and no longer ship RPMs.
Yeah, so
The only way to get the graphical LibreOffice is via Flatpak.
yeah, well, so I mean, eventually, I don't know, there was that, I think my position on this is that we will not, in any short term, you know, in the short term, we encourage people to build both classical and Flatpaks. In the medium term, if a packager wants to not build the classical form of application, they can do it. And any long-term entire move to Flatpaks is beyond my current horizon. And yeah. So, one last question. Yeah.
When someone installs an OCI container packed Flatpak,
Yeah.
how is it handled locally? Does Flatpak create an OS3 repository in local machine?
Yeah, so it's unpacked into an OS3 repository locally. So there's no difference between after installation. So in fact, if you have two, like say if you have two different runtimes that have a lot of the same files installed, those will be deduplicated locally, and you'll save disk space. You just won't save network bandwidth. Okay, well, thanks everybody.
So, once again, I would like to remind you, in 20 minutes, there is a surprise to the program. So, thank you very much.
The HMI actually worked most of the time.
Yeah.
That was.
So we will keep it there.
Very Myers. I wasn't sure if it was a good question. I forgot to ask two questions. One, do you know anything about the video stuff that's going on? It's like and they've got a block layer that you can stick on top of any other block layer. And as I was thinking about like moving towards Flatpak, there's going to be a lot of duplication.